Okay, let's take a look at what question 1 is asking us here. They want us to find I/O in this circuit below, where I/O is right here. So we see that we have a current source, and looking at our current source, we see that 18 amps are going to come up through here, hit this point, see this node split off into 2 different directions, and we're trying to find I of O right there. So in order to find out what the I of O current is going to be, we'll need to employ the current division equation. So current division. Okay. For that, we need this to be in parallel. And we're almost there, but not quite. We need to find an equivalent resistance across this branch so we can get the R parallel. Okay. So we go break these right side down. We see that these are going to be in parallel, so I'll call that R parallel 1. So R parallel 1 is equal to 6 times 3 over 6 plus 3. 18 over 9 should give us 2 ohms. 18 amps. 12 ohms. 4, and then we have 2 right here. Okay. And we still have our 18 coming this way, splitting off down both of these ways. Okay, and we see that these two are in series. So I'll call that series 1. So R series 1 is equal to 4 plus 2, which will give us 6 ohms. Okay, we redraw again down here. We will have 12 ohms, then we'll have 6 ohms. And then finally, 18 amps split up this way and that way. Okay. And then finally, we see that these two are in parallel, so I'll call that parallel 2. So R parallel 2 is equal to 12 times 6 over 12 plus 6. Which should give us 4 ohms. Okay. And therefore, we end up with this circuit, 4 ohms. Okay. We have 18 amps going that way. So our R parallel 2 is equal to our R equivalent. So therefore, to find I of O going down this way, all we need to do is find I of O is equal to R equivalent over 12 ohms times I of the source, which in this case will just be 4 ohms over 12 ohms times 18 amps, which should give us a total of 6 amps for I/O. Okay, and just as a quick check for the other branch, if we were to call this one, we'll say I1. So if I1, this is R equivalent over 6, because it's the total resistance of that branch. Okay, so 6 times IS. So if we did 4 ohms over 6 times 18 amps, that should give us 12 amps for I of 1. Okay, and if we were to check that with KCL, I of 1, I of source, and I of, that's I of 0. So it would be I of source is equal to I of 0 plus I of 1, which is 18 is equal to 6 plus 12. So 18 is equal to 18, and we are looking good.